Imagine trying to measure the Earth when you cannot leave it, cannot see it from space, and have nothing like a satellite, a telescope, or even a clock that would satisfy a modern surveyor. Imagine standing in a city of scrolls and arguments, hearing that on one day of the year, in one place far to the south, the sun shines straight down a well, while in your own city, at that same moment, it throws a shadow. Most people would call it a curiosity. Eratosthenes turned it into a planet-sized calculation. And in doing so, he did something even larger than measuring the Earth. He helped make the world itself into something that could be described, compared, mapped, dated, and reasoned about. This is why Eratosthenes matters. Not because he was good at one thing, but because he was one of those rare minds who seemed to look at a civilization's scattered knowledge and ask, can all of this be turned into a system? Geography, chronology, astronomy, mathematics, literary criticism, poetry, even the flood patterns of the Nile. Again and again, he tried to take fragments and make them cohere. Later generations sometimes mocked him for that range. His admirers called him pentathlon, like an all-around athlete. His critics called him beta, second best at many things, first at none. But that judgment misses the point. Eratosthenes was not trying to win one event. He was trying to understand the shape of the world. He was born around the 270s BCE in Cyrene in North Africa, today's Libya, a Greek city with its own intellectual traditions. He studied with scholars connected to both philosophy and poetry, including Callimachus, and then spent years in Athens, the old capital of Greek intellectual prestige. There he encountered Stoics, Platonists, rhetoricians, and poets. He sampled almost everything. That eclectic training mattered. Eratosthenes would never become a narrow specialist. He wrote philosophical works, including a Platonicus. He wrote poetry, including a poem called Hermes, and he emerged not as a single discipline technician, but as a thinker formed by the entire Hellenistic culture of learning. Then came Alexandria, the great machine of knowledge. After study in Athens and Alexandria, Eratosthenes was brought to Alexandria under the Ptolemies, became tutor to the royal household, and rose to become head of the great library, housed within the Mausoleum. This was not just a building full of books. It was one of the most ambitious intellectual institutions the ancient world ever created, a place built on collecting, organizing, and comparing the knowledge of many lands. Eratosthenes was almost made for it. As librarian, he stood at the center of an empire of texts, routes, reports, measurements, poems, histories, and arguments. If any place in the ancient world could tempt a mind into trying to measure everything, it was Alexandria. And this is the deepest way to understand him. Eratosthenes did not merely know many things. He believed that many things belong together. Geography should not just be travel tales. It should be mathematical. History should not just be a sequence of local legends. It should be chronological. Prime numbers should not just be noticed one by one. They should be generated systematically. Even the Earth should not just be inhabited, it should be measured. His most famous feat begins with one of the cleanest ideas in the history of science. At noon on the summer solstice, the sun at Syene, modern Aswan, was said to shine straight down, while in Alexandria, at the same moment, a vertical object cast a shadow. Eratosthenes measured that angle in Alexandria as about 1/50th of a circle, roughly 7.2 degrees. If the sun's rays are effectively parallel when they reach Earth, then that little angle on the ground corresponds to a central angle at Earth's center. And if the arc from Alexandria to Syene is 1/50th of the full circle, then the whole circumference of Earth must be 50 times that distance. It is one of those moments in history when the world suddenly becomes legible. The elegance of the idea can make us miss its boldness. Eratosthenes was treating Earth not as mythic terrain, nor merely as a backdrop for empires, but as a geometrical body. That is the real revolution. The calculation itself is reported in later sources as 250,000 or 252,000 stadia, and the exact accuracy depends on the length of the stadion he used, which remains debated. But even allowing for that uncertainty, his result was astonishingly good, close enough that modern historians still marvel at it. And one widely cited reconstruction puts it within about 1% of modern values. The exact number matters less than the act itself. A human mind, using light, distance, and geometry, had reached for the size of a planet. And Eratosthenes did not stop at the circumference. He pushed toward what we would now call mathematical geography. The very word geography is tied to his Geographica. Britannica notes that the separate identity of the discipline was first formulated and named by the Greeks, with Eratosthenes' Geographica as the title that helped define it. In that work, he tried to make geography something more than a bag of stories. He rejected the idea that Homer was a trustworthy mapmaker and instead organized places by measured distances and positions. His map, though crude by modern standards, anticipated a gridded world, something like latitude and longitude, and absorbed new knowledge from Alexander's eastern campaigns. He was not just drawing places. He was inventing the intellectual habit of locating them within a system. That same instinct drove his work on time. Greek cities had their own local calendars, local traditions, local founding myths. Eratosthenes wanted a common chronology. His Olympionikae assembled lists of Olympic victors as a chronological spine, and his Chronographiae organized events from the Trojan War to the death of Alexander into one coherent timeline based on Olympiads. Britannica explicitly credits him with working on the systematization of chronography in the late 3rd century BCE. This is easy to overlook today, but it was a profound act of intellectual ordering. Eratosthenes was trying to do for history what he had done for space: create a framework in which scattered events could be compared and synchronized. Then there is mathematics. School children still encounter his name through the Sieve of Eratosthenes, the procedure for finding prime numbers by listing integers and repeatedly striking out multiples. It is ancient, simple, and conceptually beautiful. Instead of testing each number separately, you filter a whole field of numbers by structure. That is a very Eratosthenian move. System over anecdote, pattern over isolated fact. Britannica still defines the sieve as a systematic procedure for finding primes, and modern mathematical resources still present it as a practical algorithm for generating prime tables. His name survives not just in history books, but in the way mathematics is taught, coded, and thought about. He also worked on one of classical Greek mathematics' most famous challenges, doubling the cube, the so-called Delian problem. Ancient sources credit him with a solution involving means and with designing a mechanical instrument, the measurabe, to demonstrate it. This is another revealing detail. Eratosthenes was not only a theorist of abstract order, he was also willing to build devices to make mathematics tactile, visible, constructive. In Alexandria, he is said to have commemorated this achievement with a monument displaying the instrument, the proof, and a poem to his royal patron. Even here, the same personality shines through. Mathematics, mechanics, patronage, public display, and literary culture all fused into one act. His range went further still. He worked out a calendar that included leap years. He is said to have compiled a star catalog of 675 stars. He wrote on theater, ethics, grammar, and ancient comedy. He studied the Nile and sketched its route toward Khartoum with surprising success, even suggesting lakes as its source, and giving what Britannica calls an essentially correct explanation for the flood pattern. Heavy rains in the southern regions feeding the river downstream. He also described parts of Arabia and tried to sort peoples and places with the same classificatory confidence he brought to maps and dates. Much of this work survives only in fragments or later testimony, but the pattern is unmistakable. Eratosthenes kept returning to the same question: can knowledge be organized well enough that the world stops being a collection of marvels and becomes an intelligible whole. There is another reason he matters. Archimedes, perhaps the greatest mathematician of antiquity, valued his opinion and corresponded with him on mathematical issues. That detail alone tells you how Eratosthenes was seen by the best minds of his age. He may not have been Archimedes in raw mathematical brilliance, and the ancient jab of beta suggests as much. But he was the kind of scholar to whom Archimedes wrote, the kind of scholar whose judgment mattered, the kind of scholar around whom the mathematical and intellectual life of Alexandria could circulate. In old age, the story darkens. Ancient tradition says he went blind and, unable to continue his work, died by voluntary starvation in Alexandria around 1940 BCE. Whether told with pity or admiration, the anecdote fits the aura that surrounds him. A man whose life was so bound to intellectual activity that the loss of sight became, in some sense, the loss of his world. It is a hard ending for someone who spent his life trying to see farther than almost anyone else. And yet, his afterlife is enormous. His Geographica became a major authority for later geography. Even when Strabo criticized Eratosthenes, he preserved crucial evidence of his work. And later, geographers such as Ptolemy operated in the world Eratosthenes had helped create. A world in which astronomical data, route distances, and mapping belong together. Britannica's history of geography still points back to him at the naming of the discipline. His measurement of Earth stands near the beginning of geodesy, the long tradition of determining the shape and size of our planet, and in a beautiful historical irony, later figures sometimes ignored the better size estimates he represented. Britannica notes that Columbus relied on smaller ancient values, not on Eratosthenes' larger and more accurate one, when selling the westward voyage to Asia. His legacy also reaches into classrooms, algorithms, and the modern imagination. Students still recreate his Earth measurement with sticks and shadows. Number theory still teaches his sieve. Historians still rely on the chronographic impulse he embodied, the drive to synchronize events across cultures and records. And the most modern disciplines, cartography, geodesy, global mapping, even computational thinking, still live inside habits of mind he helped establish. He did not discover everything he touched, but he helped define what it means to turn the world into an object of inquiry, measurable, mappable, datable, comparable. So perhaps beta was the wrong name after all. Maybe Eratosthenes was not second best in many fields. Maybe he belonged to a rarer category altogether, the people who change the scale at which civilization thinks. Before him, the Earth was known, traveled, fought over, sung about. After him, it was also something you could calculate. Before him, place and history and number could remain separate pursuits. After him, they could be drawn into one intellectual project. And that is why Eratosthenes still feels modern, not because he anticipated satellites, but because he understood something their builders would later inherit. The world is not only where we live, it is something the mind can measure. If you want, I can turn this into an even more uploaded script-style version with sharper hooks, more retention-driven transitions, and stronger scene-by-scene visual cues for editing.